Hey, what's up, linear algebra bros? It's Mr. C here, and in this video we are going to use the Wronskian to determine if this set of vectors is linearly independent. Alright, so this function right here can serve as our f sub 1, this is our f sub 2, and this is our f sub 3 vector. And the Wronskian will be a determinant. And since we have three functions, we're going to want this determinant to be a 3 by 3. So we'll need not only the first derivative of each of the functions, but also their second derivative. So in the first row is going to be just the original version of each function. In the second row will be the first derivative of these functions, so 0, 1, and e to the x. And then the second derivative of each of these functions, which will be 0, 0, and e to the x. Now notice that we have a triangular matrix. In particular, it would be an upper triangular matrix. And due to that fact, all we have to do to evaluate the determinant is just multiply the entries along the main diagonal. So it's going to be 1 times e to the x, which gives us e to the x. Alright, that would be part 1 of this more or less two-step process. Okay, notice that e to the x is not identically equal to 0. So we could, base our conclusion by the results of step 1. Or, what you could do to be a little more concrete about this is pick a value of x to plug into e to the x. Use something easy. I think I'll roll with 1 this time. So w of 1 is equal to e to the first, which is equal to e. Now that's obviously not equal to 0, which implies that the Wronskian is not identically equal to 0. Therefore, the set of vectors f sub 1, f sub 2, and f sub 3 is linearly independent. Okay, and conceptually that means that we would not be able to write any of those three functions as a linear combination of the other two. So the number 1 cannot be written as a linear combination of x and e to the x. The function x cannot be written as a linear combination of 1 and e to the x. And last but not least, e to the x cannot be written as a linear combination of 1 and x. Alright, so that's the concept, and we were able to prove that fact using the Wronskian. Alright, and that's where this video ends. Let me know if you have any questions. Otherwise, thanks so much for watching. See you later.